Good evening, all of you. My name is MD Parvez, and today we will discuss about the derivation of magnetic field formula due to straight wire. Okay. Suppose we have wire of finite length. Okay. Suppose we have wire of finite length. Okay, finite length, suppose 10 meters. Okay, now suppose this point is given, suppose this is P, and we have to calculate the magnetic field. We have to calculate the magnetic field we have to calculate the magnetic field at given point P. Okay, at given point P. So what is the procedure? Okay, so first, this is point given point P. So step first, we draw a perpendicular distance. From wire, distance from given wire. Okay, from given wire. Suppose this is point P. Okay, now perpendicular distance is this. This is perpendicular distance. So this is angle is 90 degree. Okay, now step first is this, and step second is we select a DL element. From wire, from given length of wire, Okay, so this is the length of wire, and I have already mentioned that length is 10 meters. So first we select a DL element from this wire. This is DL, and in Bio-Savart law, actually ideal is current element, and this is the vector quantity. Okay, now second and the third step is we connect the given point to DL element point. Means basically this is first point, given point, at which we have to calculate the magnetic field, and this is DL element point actually. So we have to connect both points. Okay, so this is okay, and this is suppose vector R, and suppose this angle is like theta. Now this angle is 90, and this angle is suppose alpha. Okay, now third step is, okay, so first step is we draw a perpendicular distance. Suppose we have to calculate the magnetic field at that point. So first we draw a perpendicular distance from this point to this given length of wire. So this is the perpendicular length, and this angle certainly is like 90 degree. Now second step, we select a DL element from given wire. This is wire. Suppose length is 10 meter. So we select a DL element. So I have selected here DL element, and actually DL is not a vector. So for making vector, we have to multiply it by current. So ideal is current element, and this is DL element. Okay. Now ideal is vector, and this is also vector. Okay. Now this is angle alpha, this is angle phi. Step 3, we connect the point through dual element point. Okay, now this is r vector. And step 4. Step 4 is step 4. Step 4. We connect the given point. We connect the given point from both end of wires. Both end of wires means, it means that suppose we have two ends of wire. This is suppose first end and this is second end. So at which point, that point we have to calculate the magnetic field. So connect this given point from end point of wire. So this is and this is. Now suppose angle subtended here is like, suppose angle phi 1 and suppose here angle is phi 2. Actually this is the base. Okay, this is the base. So this angle is like in clockwise and this is in anti-clockwise. So in anti-clockwise we mention here like negative, and for clockwise we mention here positive. Either if for anti, like note that we assume that anti-clockwise angle is measured in negative terms. Means anti-clockwise angle in negative terms and clockwise angle in positive terms. Okay, so this is clockwise angle, so this is plus phi 2 and this is anti-clockwise angle, so this is minus phi 1. Okay, now according to Biot-Savart law, okay, according to Biot-Savart law, magnetic field due to this small element dl, okay, magnetic field dB means due to this small element dl. So value of dB is mu naught I upon 4 pi dl cross r upon r cube. Okay, now here actually this is dl vector ideal and this is r vector, and means like this is different vector and this is also different vector, and angle subtended between both vector is theta. Okay, so the ideal cross r vector means ideal into r into sin theta. So dB value is here mu naught I upon 4 pi dl r sin theta upon r cube. So first r and here r cancel out here, r square. Now dB value equals to mu naught I upon 4 pi dl sin theta upon r square. Okay, now further in this is actually point P. In this triangle P, this is suppose this is L and this is M. So in triangle PLM, okay. Now this is basically P and this is basically L and this is M. This angle is 90 and this angle is here theta and this angle is alpha. Suppose this length is A and this length is L. Okay, so this is L length and this is A length. So tan alpha equals to L by A. Okay, so L equals to A tan alpha. Now differentiate it. So dl equals to here there are two terms A tan alpha. So A is constant. So A sec square alpha d alpha. Okay, now here suppose this is sine theta. In this triangle the sum of all angle is 180. So 90 plus this angle theta plus this angle alpha equals to 180. So theta plus alpha equals to 90. So theta equals to 90 minus alpha. Now here, okay, so I have first theta equals to 90 minus alpha, and second dl equals to a sec square alpha d alpha. Okay, a sec square alpha d alpha. Okay, now in next value of r. So value of r is, this is r actually. So value of r is cos alpha equals to base is this is a upon r. Value of r is a cos alpha, further a sec alpha. This is the value of r. Now put here all value. dB equals to mu naught I upon 4 pi. Value of dl is a sec square alpha d alpha. So a sec square alpha d alpha. Value of sin theta. Actually sin theta means sin 90 minus alpha. So here sin 90 minus alpha is cos alpha. So 90 minus alpha, and upon this is r square, and value of r is this. So r square means like this square. So here a square sec square alpha. Okay, now next here magnetic field value is equals to B. Actually B is the net magnetic field due to given wire. So mu naught I upon 4 pi, and this is sec square alpha. So sec square alpha, this is sec square alpha and this is also sec square alpha. Cancel out. 1a here cancel out. So 1a is remaining here. Okay. So a here. Okay. Now alpha d alpha sin cos alpha. So cos alpha d alpha from, actually this is upper lower limit, and lower limit is minus 5, and this is upper limit plus 5. I have already discussed that. This is basically in anti-clockwise. So we like minus, and here plus. This is clockwise. Okay. So anti-clockwise minus 5 and this is plus 5. So minus 5 to plus 5. So magnetic field B equals to mu naught, here also minus 5 to plus 5. Okay. Now mu naught I upon 4 pi a, and value of cos alpha is minus sin alpha. Value of cos alpha is minus sin alpha. Okay. So magnetic field B equals to mu naught I upon 4 pi a, and this is minus sin phi 2 plus sin phi 1. Okay. Now magnetic field equals to mu naught I upon 4 pi sin phi 1 minus sin phi t. Okay, so this is the formula for calculating the magnetic field due to straight wire. Okay, thank you.